Hello everyone, bonjour à tous. I'm Mariana and I will be talking to you about dealing with climatic uncertainty on hydrological projections. So first of all, what are these hydrological projections? So as you know, climate scientists simulate the climate of the world in order to better understand the effects of climate change. So this looks more likely like this. We create a grid around the globe and at each point of this grid, we can obtain climate data, right? These climate data can look like this. For example, for a year, we have precipitation, temperature, and many more data that we hydrologists then use to feed our hydrological models that allow us to obtain these hydrological projections of the future in terms of stream flow, right? So I think we're happy, we have a response, we can be happy and then make our analysis of the future, right? Well, it's not actually that simple because we don't have just one perfect model. We in fact have tens of climate models that then get translated into tens of stream flow simulations, right? So now we're more like stressed about it rather than happy to make our analysis. So how do we actually manage all this information? Well, one of the dominant approaches, as you can see here, it's the so-called climate models democracy. This democracy means that we give equally probability to all the models possible. So in other words, we keep them all and we assume that are all equally plausible. And at the end, we end up with some simulations like this, where we create this envelope of uncertainty, as you can see in gray for historic and future. And as a baseline, well, we use the mean or the median that you can see on the blue line. But in fact, this has many issues because many of these climate models are actually replicating big parts of their codes, so they're not independent. And many of them have actually very bad performance at the regional scale, which is bad for hydrological studies, right? So what do we propose? We propose weighting climate simulations based on their independence and also their performance. We actually applied 6 different methods of weighting on over 96 basins that cover a very high diversity of hydroclimatic conditions. And at the end, we obtained very interesting results looking something like this. Instead of having these big envelopes of uncertainty, as you can see on the gray, we were able to reduce them, as you can see on the green envelopes. This can have a very big impact on how we actually analyze our results on hydrological projections for flood, for dryness, and many other things that we analyze. So this reduction of the uncertainty on hydrological projections actually underline the need to reconsider the so-called climate models democracy, especially for hydrological studies. If you have questions, you can take a peek on the right corner and contact me for further information. Thank you.